All right, guys, we are in page 156 of your student journal, starting chapter 5, probability. So the intro section is sample spaces and probability. Sample space is just another way of saying like all the things that can happen. So finding the sample space of an experiment. The sample space of an experiment is the set of all possible outcomes, which is just another way of saying everything that can happen for that experiment. Work with a partner. In an experiment, 3 coins are flipped. List the possible outcomes in the sample space. So they start off with this example, heads, heads, tails. But for the sake of this, I think it's easier if you start off kind of systematically and you approach it kind of uniform. So I would say heads, heads, heads. Then instead of heads, 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 it could be heads, heads, then tails. And so on and so forth. Since we're just at the beginning of this, I will go ahead and list all of them out. So it could be heads, 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 tails, heads, tails, heads, heads, tails, tails. And then let's swap to the tails, starting with the tails. We could have tail, tail, tail. We could have tail, tail, head. We could have tail, tail, head, tail. And tail, head, head. So list the possible outcomes. We've listed them all. There are 8 possible outcomes. Next, so I mean, if you think about it, like these are all distinct and different things. So you know, if you flip a heads, then a heads, and a tails, that is different from flipping a tails, then a heads, and a heads, right? Depends on when you flip that tails, whether it's first, last, or even in the middle, like it is here. So yeah, moving on. List the possible outcomes in the sample space of the experiments. So so you could roll one 6-sided die, right? So it's like, okay, you could roll a 1, a 2, a 3, a 4, a 5, or a 6. Now this one gets a little more complicated because we could roll on the first die, just like before, we could roll a 1, a 2, a 3, a 4, a 5, or a 6. And we could go ahead and duplicate that for the second die. But if we are rolling them, then here are the outcomes. Here are the actual outcomes. So we could have a 1, then a 1. But you could also have what? A 1 and then a 2. And I hope you see where I'm going with this. A 1 and then a 3. What else? A 1, then a 4, right? And so on and so forth. And so not only would you list this for the ones, but then you could also go ahead and let's switch colors. You could start with 2. Then you have 2 and 1. Right? So this is why I know it might seem tedious, or I mean, you know, it is tedious for some of you. But again, this is working on this just helps you understand how many possibilities there are, and when you work it out, you should have 36 different results written down. That's because for each one, you have 6 different. 1 5, then 1 6, and so for each one of these, you have 6 different outcomes. And so if you have 6 different outcomes 6 different times, then that becomes 36. Again, though, it becomes a lot easier to count if you just write them out. In an experiment, a spinner is spun. How many ways can you spin a 1? So how many 1s are there? There's only 1. How many ways can you spin a 2? So this is literally just an issue of counting. 1, 2. Okay, so there's 2 2s. How many 3s are there? And so on and so forth. So you guys go ahead and calculate the rest of those. List the sample space. So the sample space is, again, everything that can happen. So what can happen? We can get a 1, we can get a 2, a 3, a 4, or a 5. 1, 2, 3, 4, 5. What is the total number of outcomes? So right now it might look like, you might think, oh, we only have 5 outcomes, right? Which is fair for you to think, but if you look at it closely, it's like, okay, well, this is a 5, and this is a 5, and this is a 5, and this is a 5. Those are 4 different, 5s. So really what this is asking you is how many different spots can we land in? And that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this is, again, I know it seems basic right now, but it's like before you can do anything complex with these things, you got to know the basics, right? So in experiments, a bag contains 2 blue marbles and 5 blue marbles. 2 marbles are drawn from the bag. List the sample space. So it visualizes these for you. So I'll actually do it in color for you. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 2 more blue. List the sample space. Okay, so to start off with, now what I want to be obvious is that you cannot draw the first blue marble and then the first blue marble. Because if you drew this one already, then you took it out. It's not there anymore. So really what this starts off at is blue 1, blue 2, blue 1, red 1, blue 1, red 2, blue 1, red 3, blue 1, red 4, and blue 1, red 5. If I were you, and you didn't want to do this, because, I mean, I'm not going to lie, like, I have done this, and I still get mixed up by it, then you could write blue 1, blue 2, sorry. When you list these, you should, like, connect them so you know, oh, this is what I'm talking about. So I have blue 1, blue 2, blue 1, red 1, and so on and so forth until you have all of them listed out. One thing I will say is that, again, or to remind you, if I draw the first blue one, or the second blue one, I can draw the first blue one because the first blue one is still in there. But I cannot do this. I've already taken it out, so you jump straight there. And then it says, how many ways can you choose to blue? So I'll answer that for you. It should be obvious. You either draw the first one and the second one, or the second one and the first one. So the answer for this is just 2. There's only 2 ways. But then it says, how many ways can you choose a red than a blue? Which is the number of connections you have. 1, 2, 3, 4, and so on and so forth. And you guys have to count. You have to count these out. Okay, so a probability experiment is like when you actually do something to record down the outcomes. So if you're actually rolling the die, then it has to actually land on a number, right? So as opposed to when you just calculate, oh, it's 6 numbers, that means the probability of each number is 1 out of 6. Sure, but a probability experiment is when you actually do it. An event is just something that can happen. An outcome is what actually happens. Sample space, like we said before, is everything. Oops. Everything, well, that can happen. The probability of an event, just the chance that an event occurs or happens. A theoretical probability is the way I think about it in my mind is a calculated probability. So what you expect to happen. And an experimental probability is what actually happened. So for instance, we flip let's say flipping a coin, right? So the easiest one. And the calculated probability of a heads or tails, it's half and half, right? 50%, 50%. So you'd say, oh, okay, well, it's 1 out of 2. But then let's say we flip a coin 5 times. And the first one was a head. And then the second one was a head. And then the third one was also a head. and you're like, oh, like the heads only has a 50% chance of coming up. Like, how could I get it 3 times? Well, it's like, I mean, you know, there's a theoretical probability, which is 50%, 50%, 50%, versus like the experimental. Okay, well, if we have 2 tails, then the experimental probability, or what actually happened, is that the tails came up 3 times out of 5 flips, right? And the tails came out 2 times out of 5 flips. And this is 60%, and this is 40%. But you guys know that in reality, or sorry, in theory, you know, it's just like, it's still only 50% chance, but it's just like, oh, this experimental probability is what actually happened, right? So there's like your one example of like, oh, experimental versus theoretical. Okay. Probability of a complement. So a complement is just like something not happening. So like some examples are like flipping ahead, not flipping ahead. Eating a bagel or not eating a bagel. So a complement is just like, oh, you have an event, and the complement is just, oh, that event not happening. Find the number of possible outcomes in the sample space, then list the possible outcomes. So this asks you for a number and what is actually happening. So a stack of cards contains the 13 clubs. So these are 13 clubs: ace, deuce, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. These are the clubs. That's the suit. And then you flip 2 coins. So I will start off listing, but it's up to you to finish. So you could have the ace, and then we could have head, head. You could have the ace, and you could have what? Heads, tails. You could have the ace, and you could have tail, tail, and then you could have the ace, you could have tails, then heads. So you guys got to do that for the rest of them. So I have found 4 possible outcomes so far, but this is just with the ace. You have to do it with the rest. You spin a spinner with the numbers 1 through 5 on it. So I'm going to try and make a reasonably spaced one. And pretend these are even spaces, even though I know I drew them terribly. So we have 1, 2, 3, 4, 5. And roll a die. So we have a die, you know, with 6 sides. So we could get a 1 and then a 1 on the die. And don't forget that, like, a die has 6 sides. So I could spin a 1 and then roll a 1. I could spin a 1, then roll a 2. I could spin a 1, then roll a 3, and so on and so forth. Okeydoke. When 2 tiles with numbers between 1 and 10 are chosen from 2 different bags, there are 100 possible outcomes. Find the probability that the sum, that means when you add them, the sum of the 2 numbers is not 10. So again, we have the setup 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we duplicate that over here. And then it says find the probability that the sum is not 10. So this is not 10. 8, 9, 10. So if you connect these, we have a 1 on 1. That's not 10. That's not 10. That's not 10. That's not 10. So basically, you guys have to count the number. Find the probability that the sum of the 2 numbers is not 10. So you'll create a fraction for this, and it will be the number of sums that are not 10 over the total number number of sums, which they told you there are 100 possible outcomes, or so I should say total number of outcomes, sure. And next, the product of the numbers is greater than 10, so then you would, using this framework, you would count, okay, if I multiply this, how many of them come out greater than 10 in total, not just for like one, right, but like, 2 times 1, 2 times 2. And again, over the total number of outcomes, which they've already given you, is 100. The last one I will work with you is at a school dance, the parents sell pizza slices. The table shows the number of pizza slices that are available. A student chooses a slice at random. What is probably the student choose a thin crust slice with pepperoni? Thin crust slice with pepperoni. Boom. 34. Over, how many slices are there? How do you find that? You have to add all these up. So 34 over the total. 34 over the total. Okay, and then this one, it's basically asking you to factor x squared minus x, and it says, can it be factored if c is randomly chosen from 1 through 12? So 1, x squared minus x minus 2, x squared minus x minus 3, 4, 5, and then it's the question is how many of them can be factored. So for instance, x squared minus x minus 6 is one of them, because you could factor as x minus 3 and x plus 2. So out of these 12, out of the 12 total, which means that the total outcomes are 12, how many of them can be factored? So you have to figure out this part. And I have done one for you, but you have to find the other ones. Lastly, the sections of a spinner are numbered 1 through 12. Each section of the spinner has the same area. You spin the spinner 180 times. So if it's equally, each section has the same area, then you would expect them to have an equal chance, right? Now we've done it, and it's clearly different because that's the way reality works, but it says which number is the experimental probability, which is what actually happened, is the same as the theoretical, in theory, if you take 180 and you split it across 12 numbers evenly, you would expect it to happen 15 times. So you go ahead and use that information, answer this question, and then you have a couple more questions here. If you're confused or something like that, I know we haven't gone over odds yet, so you should be asking me questions. I will go over this with you individually. That's the end of the video. So good luck, and make sure you pay careful attention to detail when you count these outcomes.